All right, guys, so this for us is our first new lesson. We didn't cover this before March break. Um, we are going to get into it now and see how this type of learning works for you. We're going to get into something called expanding quadratic expressions. Now, we have done expansion before, and we'll do an example. We did it and should have done it in grade 8. You definitely did it in grade 9, but we only looked at very specific cases in grade 8, grade 9. So now we're going to get into something a little different. Now, before we get too far in, let's cover a few definitions. So a monomial is a single term. You might remember that mono means one. Think of monorail. Okay, so whether it's and a term is anything, any value really. So it's any numbers that are multiplied together. And yes, I know you all look at the letters and go, that's the alphabet. It doesn't count as a letter. It actually is because the variables are numbers we don't know. So this really is one number, just as this is really one number. A binomial is two terms. And you can tell that they're two terms because they're separated by a plus or a minus sign. And keep in mind, thinking about the differences in like terms, just because these both have h's does not mean that they are the same. One has an h, one has an h squared. So don't make that mistake. Finally, we have a trinomial. Tri means three, right? Think about your tricycle. Just like binomial means two. Think about your bicycle. And same rules apply. They're separated by addition subtractions. And even though the variable might be the same, if the exponents are different, they are not considered the same thing. Now, last year you would have looked at something called the distributive property. And what happens is that whatever's on the outside of the brackets gets multiplied by everything inside the brackets. So here we have 2a. So it means that the whole thing gets multiplied by a and multiplied by 3. Now, you don't have to include this step. I'm just showing, since it's a plus 2a, it's a plus. I'm just showing how we come up with that next line. A times a is a squared. And we are done. A squared is not the same as a, so we can't combine them. So you give it a shot. See if you can remember how to expand. Now, all I'm expecting out of you is negative 2x squared plus 10x. So once again, you don't have to show me that thinking step. You have to do it, but you do have to do it properly. Negative 2 times 1 is negative 2. X times x is x squared. Negative 2 times negative 5 is positive 10. And then you don't lose the x. All right. Now, I am never a fan. Oh, hey, look at that. I'm never a fan of the area model, but some people understand it better. So what ends up happening is that we take our letters and what happened there? We put them into a little box. And likewise for the other one, but we put them down the other side. And we multiply them wherever they meet. So in the first box, we have x times 3x. Wow, that's horrendous. The second box, we have 2 times 3x. The third box, we have x times negative 4. And the third box, we have 2 times negative 4. And we turn around and write out our values. Once we have our numbers written out, we then turn around and collect like terms. So there is no other squared. 6x minus 2x is plus 2x, and there are no other plain Jane numbers. So we rewrite it out. I prefer the FOIL method. As you can see, I've worked it up a little bit better. And what FOIL stands for is that we're going to multiply the firsts. So that's the x times the 3x, because they're first in their brackets. We're going to multiply the outsides. So that's the x and then the -4, right? See how they're on the outsides of everything? We're going to do the insides. So that's the 2 and the -3. And then we're going to do the lasts. So the last one in the first bracket times the last one in the second bracket. And it works out to the same thing. It's just that instead of thinking of it as a giant square, we're thinking of it as double rainbows. Notice, of course, that you get the same answer. And it doesn't matter what the values are. So this one we have a slightly more complicated 3x instead of just an x, but it doesn't make a difference. It's first term times the last term. So if we multiply it out, -3x squared minus 24x plus 5x plus 40, and then collect like terms. -24 plus 5 is -19x plus 40. So at this point, it's really only those last two terms that you have to worry about. Give B and D a try. And then if you're feeling brave, come back for C. Okay. Now the reason I wanted you to leave C to the end is that we've got that dreaded exponent yet again. So now we got to look at this and figure out how does it relate to what we've been doing? Well, that squared, what it means is that we're taking whatever's inside the brackets and multiplying it by itself. All of a sudden, this follows exactly the pattern that we've done. But you have to remember what that exponent means. So, determine a simplified expression for the area of the rectangle. Simplified means as few terms as possible. I really hate writing with my finger. I'm looking forward to tracking down a stylus. Oh, gonna have to expand this. Hopefully you remember this, but area of a rectangle is length times width, which means we're doing 2x minus 1 times 4x plus 3. 8x squared. Ta-da! Now, what happens if you have an a value? And recall that A is a number in front of everything that multiplied by the whole gobbledygook. And the answer is, it really doesn't change anything, but now you have some options as to how you proceed. Option 1 is that we could ignore the A and move forward as though it's not even there. Oops. Arr. And this is, had the A value been 1, had it not been there at all, this is how we would have solved it. At this point, we can now expand into the 3 terms that are left. So it ends up being negative 3x squared plus 3x plus 90. The second option is we could choose to multiply A in first. So just because they're side by side, notice though, a common mistake is that people want to multiply the 0.5 times the first term and the 0.5 times the second term. Okay, it goes into one or the other, not both. It doesn't matter which one. I could have done 0.5 times x minus 2, but one or the other. Remember, 0.5 x times 2 is 1, and I changed the sign. Actually, I don't need the brackets anymore. I don't know why I included them. I'll get rid of them in this step. And there you go. So it's not a whole lot different than what we've already been doing, but there is that extra step that goes along with it. All right, so the Rainbow Bridge in Utah is a parabolic in shape. The arch is 88 meters high. It's 84 meters across its base. Determine a quadratic equation that models the shape of the arch. Now, the honest answer is here, we can put a grid on this thing any way we want, but the laziest way, the easiest way, is to put one side of the arch right at 0, 0. So what it means is that the other side of the arch is at 84, and it says it's 88 high. Remember which format we're starting with, and we can start substituting in okay, now that I've done this, we can start substituting it in, but the problem becomes we don't have a third point to sub in. So we got to change things up a little bit. Sorry, I hate giving examples and then having to rework the examples, but it's just to show I don't have all these things memorized. Sometimes I have to figure out a few things along the way. And I don't expect you guys to memorize everything either. But if your skills are there, you can manage to sort life out. All right, so we'll try that again. So this length, there we go, 88 high. It's 84 across, which means this is negative 42 and this is positive 42. So now we have enough information that we can solve this equation. The vertex is at 0, 88, right? Because we put the top of the arch at exactly underneath the where x equals 0. We did that by design. And since the arch is a perfect parabola, we know that the half on the left has to equal the half on the right, which is where we got these two values from. We can start substituting in. Now, I am changing the signs. So the one on the left, negative 42, is my plus 42 in the equation. The one on the right, the positive 42, is my negative 42 in the equation. It might look like I'm cheating, but I'm not. Okay, sorry, I needed a calculator there. So other than putting this in the lowest terms, we are finished. 22, that's 17 divided by 4, 4, 1 equals A. And no more we can do with that. And there's our equation. If you want to put it in as a decimal, you're welcome to. I prefer fractions. It's a lot more accurate. And again, I've been encouraging you guys to get into that habit. We are done for the today. There's your homework. Have fun.